Now that we've studied the double angle identities, it's time to take a look at the half angle identities. And we do that by starting with a couple of the double angle formulas. So let's take a look. One of our double angle formulas is cosine 2 theta equals 2 cosine squared theta minus 1. And what we're going to do is simply solve this for cosine theta, and then we'll transform that into a half angle formula. Here's how that works. To solve for cosine theta, first we'll add 1 to both sides, and we'll end up with cosine 2 theta plus 1 equals 2 cosine squared theta. Then we'll divide by 2 on both sides. In other words, we're just doing some basic algebra here. And the other thing I'm going to do is I'm going to switch this equation around so that I end up with cosine squared theta equals cosine 2 theta plus 1 over 2. And now to solve for cosine of theta, I simply take the square root of both sides. And I'll end up with the cosine of theta. And remember, there are two square roots. There's the principal square root and the negative square root. So I'm going to indicate that with a plus minus sign. And then I'll have the square root of this whole thing on the other side there. And this is what we call our half angle formula. Notice right now we don't see any fraction of 1/2. What we're going to do is just transform this, and I'm going to say that alpha equals 2 theta, and then if you solve for theta, you get theta equals alpha over 2. And so my first half angle formula looks like this. Instead of writing the cosine of theta, I'm going to write the cosine of alpha over 2, because that is theta, equals plus minus the square root of, instead of cosine 2 theta, right here, I'm going to put alpha in its place. So I get the cosine of alpha plus 1 over 2. And this guy right here, even though I squeezed it in on the bottom of our little slide here, this is our half angle formula for cosine. The cosine of alpha over 2 equals plus minus square root of cosine alpha plus 1 over 2. And we can do the same thing, or something very similar, I should say, to come up with the sine of alpha over 2 formula. So let's do that one now, and then I'll show you how we're going to use these in our assignment. If we go back to one of our double angle formulas, this time the one that includes sine squared theta, and we do the same process, we solve for sine of theta, we can develop the other half angle formula. I'm going to need to be careful with this negative sign right here, but I'm basically going to subtract 1 from both sides. And I'll end up with cosine 2 theta minus 1 equals negative 2 sine squared of theta. And then I'm going to divide by negative 2, but I'm going to be careful how I write that. So the first thing, keep in mind, I'm going to do a little switcheroo here like I did on the other slide. When we cancel these 2's, I'm just going to write the sine squared of theta over here, because this is the thing I'm solving for, and we like to have that on the left typically. When I divide cosine 2 theta minus 1 by negative 2, I want to end up with a positive 2 in the bottom of this fraction. So I'm going to multiply the top and bottom by negative 1 in the process. So I'm going to multiply by negative 1 on top and bottom. That gets rid of the negative 2 in the denominator. Turns it into a 2. And then what it does is it basically switches the order of the cosine 2 theta minus 1, and it becomes 1 minus cosine 2 theta. And then just like we did in the other slide, we'll take the square root of both sides, and we'll come up with the sine of theta equals plus minus square root of 1 minus cosine 2 theta over 2. And then again, the way we arrive at what we call the half-angle formula is we introduce a new variable called alpha, and alpha is going to equal 2 theta, and that means that theta is alpha over 2. So I will replace this guy with alpha over 2, and I'll replace this guy with alpha, and I'll have our half-angle formula for the sine. So sine of, apparently I'm writing in green, alpha over 2 equals plus minus huge square root of 1 minus cosine alpha over 2. And that's all under the radical. And this guy is called our half-angle formula for sine. Try and highlight that just so you could see that's kind of a big deal. And now that we have our half-angle formulas, we're going to add those to our list of identities. And then now my job will be to show you what we're going to do with these. So let me go through 2 quick examples, and then hopefully you'll be able to give a go at your assignment. As we did with the double angle formulas, one of the exercises that you'll be practicing is to find exact values of trig functions. And we're going to need to incorporate our half-angle formulas into the process as we do this. So in this case, we're asked to find the sine of 7 pi over 12. You can think of this as trying to look at your unit circle and write down the sine, which is the y-coordinate of the ordered pair, for the angle 7 pi over 12, which of course is not on our unit circle. So what we do is we transform this into an angle that is on our unit circle. And what I'm going to do is I'm going to take that 7 pi over 12 and I'm going to double it. And the new angle that we get will be our alpha. So if I double 7 pi over 12, I get 7 pi over 6. And 7 pi over 6 is now alpha. In other words, alpha equals 7 pi over 6. And what we're asked to do is find half of alpha, right? 7 pi over 12 is half of alpha. So we're asked to find the sine of alpha over 2. And we know from the last formula that that equals plus minus square root of 1 minus cosine 2 alpha. Let's make that an alpha, not a theta. Ooh, that's wrong. It's going to be 1 minus cosine alpha over 2. That's the formula that we had. So for us, that means the sine of 7 pi over 12, which is alpha over 2, is going to equal either the plus or the minus. We're going to have to figure out the sign, and I'll tell you how to do that in a second, of 1 minus cosine 7 pi over 6, because that's alpha, divided by 2. Oh, goodness. That's supposed to say 7 pi over 6 right there. I'm going to give it a real quick shot at cleaning this up, and then we're going to move on. So basically what we do is we go to our unit circle and figure out the cosine of 7 pi over 6. There it is. And that happens to be the negative square root of 3 over 2. And so we are going to have to do 1 minus negative square root of 3 over 2 over 2. That's some kind of crazy complex fraction, but this is 1 plus the square root of 3, 1 plus the square root of 3 over 2. You can write that as 2 plus the square root of 3 over 2 over 2. And remember, we're doing a big old square root of this bad boy, which is plus minus the square root of 2 plus the square root of 3 over 4. And then usually, I'm running out of space here, we write this as the square root of 2 plus the square root of 3 over 2. And at this point, we need to decide, is our sine value going to be positive or negative for this angle? So to do that, let's just think about the angle that we used for alpha. We used 7 pi over 6 for alpha, which is this angle here. If we cut that thing in half to get 7 pi over 12, that's going to be right here, and the y value here is positive. So the sign on my crooked answer over here is positive. Square root of 2 plus the square root of 3 over 2. Crazy answer. I'm not saying that this is something that looks awesome, but oops. What I am saying is that we have found the exact value, as crazy as it looks, for the sine of 7 pi over 12. We start by identifying angle alpha by doubling the given angle. So I start right away by multiplying by 2. Once you know what alpha is, you can set up the equations so that you can do this math over here using your unit circle and careful algebra with radicals. And then right at the end, you have to decide, am I going to need the positive or negative answer? And to do that, you have to figure out what quadrant you're in. And that's what we did over here with this picture. So that's finding the exact value. There's a lot of work that goes along with it. It's not just looking at the unit circle, obviously. Let me show you one other type of problem that we'll deal with, and then we'll wrap this video up. We had problems similar to this one when we studied the double angle formulas, so we're going to attack these in the same way. Here we're given tangent of theta equals 15 over 8. We're also told that theta is between pi and 3 pi over 2. That's the third quadrant. That's just to help us make sure we know which sign our answer should have. Okay, that's for theta. And we are asked to find the sine of theta over 2. So let's just jot down that sine of alpha over 2 formula so that we can remember. And it doesn't matter if we use theta or alpha. I'm going to write alpha here just so we don't confuse the issue. Sine of alpha over 2 is going to be the plus or minus square root of 1 minus cosine alpha over 2. That's the formula that we just had in the last slide. Now, there's good news and bad news here. The good news is we're given some information about angle theta, which for us will be angle alpha. The bad news is we're told what the tangent is, not what the cosine is. We need the cosine so we can finish this thing off, and we don't have it. So for that, you do have to draw a triangle. We're going to go back to our SOHCAHTOA. We'll draw angle theta right here. And we know that the tangent ratio is 15 over 8. That means the opposite over adjacent is 15 over 8. So 15 is opposite and 8 is adjacent. From there, we can figure out the hypotenuse by using the Pythagorean theorem. When you run through the Pythagorean theorem, you get the square root of 15 squared plus 8 squared, which is 17. So the hypotenuse is 17. Now we need the hypotenuse so we can figure out the cosine of alpha, right? That's what we're trying to fill in this equation so we can finish this problem off. And we're going to need to be careful about how we figure this out. Of course, the cosine is 8 over 17, but because we are in the third quadrant, right, our original angle theta is actually in the third quadrant down here. That means the cosine is negative in that case. So we're going to say that the cosine of theta is negative 8 over 17. And then when I put it into my formula for the sine of theta over 2, which is what we're trying to find, I'm going to have plus minus. We'll figure that out in a second here. Let me just put the square root right now. It's going to be the square root of 1 minus negative 8 seventeenths, which is plus 8 seventeenths over 2. Now, let's decide, do we need the positive square root or the negative square root? If my angle for theta is this white curve here, this white arc, half of that is going to be somewhere up here. And that means the sine is positive. So for our particular angle, we need the positive square root. So I'm going to leave the minus sign off of this one. Now it's just a matter of simplifying this complex fraction. Instead of doing 1 plus 8 over 17, I'm going to do 17 over 17 plus 8 over 17, which is 25 over 17. So we're trying to figure out the square root of 25 over 17 over 2 when you do 25 over 17 times 1 over 2. This is a 7, by the way. Instead of dividing by 2, it's times 1 over 2. We really just have to do the square root of 25 over 34. And the square root of 25 is just 5, so this is really 5 over the square root of 34. And then we rationalize that denominator by multiplying by the square root of 34 on top and bottom. And so the final value for the sine of theta over 2 is positive 5 square root of 34 over 34. Crazy answer, but nonetheless, it is the correct one. Now, I have to point out to you that you have to be careful with your signs, with your positive and negative signs. So when we did this triangle over here, right, I didn't put any signs on the values. But really what we know now is that if we're in the third quadrant, both the opposite and the adjacent are negative, and that's how we end up with negative 8 over 17. Our angle was down here in the third quadrant, our angle theta, right? And then you have to imagine yourself cutting that thing in half, which looks like about where I drew this red one, and that sine value is positive because we're above the x-axis. So you have to be careful doing the calculations. There's a lot of square roots involved, but you also have to be careful with these positive and negative signs because it'll mess up your calculations. So these are a little more challenging than the double angle formulas because of the radicals and because you have to choose the sign of your answer, but they're still doable. You use the same concepts, and we'll spend a little bit of time this week working on these things. So after you watch this, give the assignment a go. Don't panic if you get stuck. You know how to find me if you have questions. And in the meantime, take care.